Thank you, Brett. And Bruce, thank you for your presentation. Actually, I have to say that project actually did progress above our expectations. So congratulations. And recognizing indeed was a strong champion. So I'm going to talk to you about the DIlbit transportation. This is the diluted bitumen transportation. It really take you through a journey of the last 4.5 years we take on to grab a public issue and see how AI-EES can contribute to a civil discussion. Diluted bitumen, as you know, is bitumen plus the diluent. Bitumen on its own is too viscous to flow. You have to add diluent to make it this flow. And the DIlbit or diluted bitumen has been transported in pipeline for over decades. However, by 2010, it became a public issue in terms of safety and environmental impact. The reason being, Enbridge had a major breach in Marshall, Michigan, spilled 1 million gallons of diluted bitumen into the Kalamazoo River. And so the public started to ask questions. Is this type of a breach really caused by the very property of the diluted bitumen? And of course, some environmental group jumped into conclusion, yes, that's the case because DIlbit is bad. So we talk upon the challenge to look at the very property of the DIlbit in comparison of a conventional crude and look at the statistic information about the DIlbit spill. And we engaged Dr. Jenny Bean at the time with Alberta Innovates Technology Futures. Jenny was is a very respected corrosion engineer with lots of experience. So the study Jenny did for us came to two conclusions. Number one, the property of the DIlbit is really very similar to conventional heavy crude and does not cause corrosions or erosions to the pipeline compared with the conventional crude. Does not cause additional. And then number two is the fact that the pipeline system carry diluted bitumen does not have the high occurrence of the breach or spill than the pipeline system carries the conventional crude. So those are the two major conclusions from that study. So 6 months later, US Congress asked the Pipeline and Hazardous Material Administration, called FAMSI in US, to conduct a study. And FAMSI turning around essentially asked the National Academy of Science to ask the very questions, same questions. Is DIlbit more corrosive than conventional crude to the pipeline? And another 12 months later, National Academy of Science reached the same conclusion as what Jenny Bean found. So we were very happy, and essentially it's a vindication of what we're being able to do and to achieve. Jenny, of course, get the well-deserved recognition in the engineering community. I got a pat from Eddie, it's a job well done. However, that good feeling didn't last very long. So people started to ask the question, what about the fate, behavior, and environmental impact of the spilled DIlbit? In case you have a spill, what is the difference of the DIlbit versus conventional crude? So for that, National Academy of Science, again asked by FAMSI and the U.S. Congress, commissioned the second study. So the second study asked a bunch of questions. What I'm paraphrasing here is really the two. Number one is, are they, the DIlbit is much different from the conventional crude in terms of the environmental behavior. Number two is more important. If they do behave differently, is the difference of their behavior warrants the changes in the procedure, in terms of emergency procedures, the spill response, warrant those changes. So those are the two key questions by the National Academy of Science. So we actually, before this put together, the National Academy of Science put it together, we were working on this already. After that study was released, we essentially organized the whole activity into 4 components to address the questions asked by the National Academy of Science, the second study, I should say. Number one is to look at the composition. Number two is to look at the physical, chemical properties, behavior. Number three is to look at the biological impact of those the DIlbit. And number 4 is to look at the actual spill cases, okay, to compare the spill cases. So in order to understand the impact of the diluted bitumen on the environment, the first place you can go is to look at the basic properties of diluted bitumen in comparison with conventional crude. So this is what we start with. And we did a bunch of study based on essentially an open database. It's called crudemonitor.com, which contains most, not all, most chemical and physical properties. And so we compiled all these informations. We looked into benzene, toluene, isobenzene, and xylene. Look at the TAN number, that's total acid number, look at the sulfur, look at the density, look at the metal concentration, and so on and so forth. I should say the crudemonitor.ca, that database is the best in the world. There is nothing similar in the other parts of the world, only in Canada. Okay, so what I'm showing here is the total BTEX, the benzene, toluene, isobenzene, and xylene. I'm showing here 35 crude oil altogether. On the left-hand side is the first 9 is conventional crude, light crude, and next to it in red is medium crude, conventional medium crude, and then there is 11 conventional heavy crude, and on the right-hand side you have 10 different diluted bitumens. So this is the comparison of a total BTEX. What you can see here is the total BTEX of diluted bitumen is actually similar, very similar to heavy conventional crude. However, it's lower than the light and medium conventional crude. Why this is important? Because BTEX are cancerous chemicals and it has the acute environmental impact. And as an example, I can show you also the density. Again, those 35 different oils are shown here. This is showing the density. Again, what you can see is the density of diluted bitumen is very similar to conventional crude. And what is also important is you note they are lower than 0.94 in terms of density and lower than water. So in the water, they should float. Okay, so I certainly cannot go through all the detail, but I can say that through this analysis, by the way, we also published this material at the international conference. So basically, from this analysis, we understand diluted bitumen and conventional crude are very similar. Diluted bitumen has high TAN values, lower contents of BTAX, and high contents of sulfur, nickel, and vanadium than conventional light and medium crude. Diluted bitumen may have less, or not more at least, health hazard and lower acute toxicity than conventional light and medium crude oils. So next is to look at the physical chemical properties. The very simple yet very important question is if the DIlbit will sink or stay afloat in a real spill situations. Why that is important? Because if the DIlbit still stay afloat, the recovery will be much easier. So that's why we go to Dr. Harvey Yarrington at the University of Calgary, did a very comprehensive study compared with DIlbit with conventional crude in a very systematic study, and the result is published in a journal. Essentially, what this shows the density evolution of Cold Lake DIlbit and a light crude over a 10 days period of time. And the x-axis is as a percentage of evaporation. So over 10 days over 10 days period, 1/3 of the diluent stays in the weathered DIlbit, and this is very significant. Every one of us, most of us, I should say, always assume when you have DIlbit is released into the environment, the diluent will go up into the sky, and that's not the case. Even in 10 days, you still have 1/3 of the diluent stay in the weathered DIlbit. And so DIlbit on own, as you can see, the density is still lower than that of the water. So DIlbit on its own will not sink upon release. However, this is a theoretical situation. In the real spill situation, you have a wind, you have a wave action, you will have a contact with the sediments in the river water. So we went to, we worked with Dr. Heather Detman at the Chemet Energy to really address this question. In the more real situation, where you have the wave action, you contact with sediments, what's going to happen? And this is what Dr. Detman built in her lab, a few cubic meters, so pretty sizable tank. You loaded this tank with the water sediments, loaded with sediments, 1,000 ppm sediments, and then you put oil or diluted bitumen on the top, and then you stir for 2 days. You let it rest for 2 days, and you stir again, and another 2 days rest. So what do we find? The result is very interesting, actually. It's totally unexpected. Cold Lake DIlbit, you have actually a thick layer of DIlbit float on the top at the end of that 8-day cycle. And it does stuck on the beach or window. But for the mixed sweet brand, the conventional crude, you actually cannot see any oil float on the top. Actually, all the oil has submerged, and no oil on the beach. And so this is a very puzzling, and certainly Dr. Heather Detman developed a theory to explain this, and I will be happy to talk about it, talk to you about this during the break. And certainly more tests are being done at the Dr. Hesman's lab. So this is essentially what I have just told you. Okay, so now we move into, we know the composition, we know physical chemical behavior, or float or sink, and we move into the biological testing now. So we went to University of Alberta, Dr. Tinnery. He's a biologist, fish biologist. We did a bunch of tests, again, very comprehensive test. The result was presented at the Canadian Zoology Society last May in Calgary. And here's showing one type of test. I should say hundreds of tests were conducted during the study, but I can only have time for one for you. What this shown here is the zebrafish embryo has a tendency or incidence of developing a disease called a PCE. Okay, so essentially this is the zebrafish is put into the solution. This solution is the toxicity or amount of the chemicals in the water is measured by water accommodated fraction, WAF, W-A-F. You can consider as WAF as the amount of the components, the hydrocarbon components, transferred into water when the oil is in contact with the water. So this is a measure. This is essentially the simple explanation. So what you can see here is in the DIlbit contact solutions, in solid circle here, the tendency to develop the PEC is actually lower, relatively lower to compare with the conventional crude. So it's a very interesting. So based on this study, Dr. Tinnery's lab concluded that mixed sweet blend crude, that is light oil, essentially, conventional crude, was more toxic than DIlbit, demonstrating that the risks associated with DIlbit are less or no different from those of conventional crude. And this is in their, essentially, the publication. Okay, and finally, we want to look at the spill case. With a natural disaster, that I mean, spill does happen. We want to take the opportunity to learn from these disasters. So what we try to do is, with the help of Dr. Martin Bunget of Alberta Environment and Parks, he was the head of the emergency responder team for the Alberta government. So we look at the two cases. One is the Marshall, Michigan case I mentioned in Kalamazoo River. Another one is the Sandre, Alberta in the Red Deer River. The two cases, although we tried very hard, tried to dig all the information, the comparison is hard, because in the Michigan case, the spill volume was about 10 times greater than what the spilled in the Red Deer River. But one lesson is common to both cases, and that's the major conclusion. No matter what type of oil is spilled, the early response, the quick response is really the key. Okay, so that's the everything, like the key point, what Martin Bunget concluded with. So I hope I didn't consume too much time here, but I want to demonstrate that AI-EES has an effective approach to address important emerging issues facing Alberta. And in terms of diluted bitumen, the safety and environmental impact, diluted bitumen does not have a unique or extreme property to make it a more corrosive or erosive to transportation pipeline. Upon spill, diluted bitumen would behave similarly to conventional heavy crude, but its acute toxicity will be less than the light oil. Emergency preparation and spill response for diluted bitumen and conventional crude would be similar. Both require fast response. So this is the last conclusion is very significant because it really addresses the core question of the second panel of National Academy of Science is asking. And that study is being finalized right now. And hopefully, again, National Academy of Science will come to the same conclusion we have arrived. With that, I do want to mention that for a small organization like AI-EES, in order for us to punch above our weight and grab an issue like this, a major issue for Alberta, we really have to use lots of brain trust in the system, in the whole, in the whole province. And these are some of the people we are working with, and we really appreciate the contribution they have made. All right, thank you. So I'm going to introduce myself next. I'm going to give you a bird's view of water and environment management at the introduction. Initially, Eddie indicated, we have a matrix organization. One of the pieces there is the water and environment management strategic area. Okay, so Margaret has, articulated that our mission is ready to position Alberta to achieve superior environmental performance while growing and diversifying the energy economy. This is certainly true for our strategic area. However, in the water areas, we also have a specific mission to help achieve government of Alberta's goal for water for life. This strategy is very unique to us. Okay, and this is talk about our ambitions. Margaret had listed the ambitions on the energy side. So for water and the environmental side, we have 5 ambitions, 5 2030 targets, from the GHG mission to the water security of the water and the water efficiency, tailings management, and habitat restoration. And these, through the last exercise, you're familiar with these targets already. And in our program, we focus on 4 major programs. The Water Innovation Program, the GHG capture, integrated land management, and tailings management. So in many of our projects, we use technology readiness level to measure the progress of environment technology development. And this is across the whole organization. Of course, for environmental technology area, we also use these measures. However, for many of our studies in water and environment, we also advance the research to support the policy development within the government and policy and regulations. And instead use technology readiness level, or TRL. We use policy readiness level to measure the progress on that side. So it's like a dual system, really, if you like. So with that, I'm going to very quickly go through some of the major programs. Of course, the Water Innovation Program, I do not need to say much more because Brett has gave you a good introduction already. I put this slide on, number one, to show the breadth of the project under the WIP program, the Water Innovation Program. Brett only introduced you 3 projects, but there is a dozen. And this is also an indication why Brad Purdy doesn't get much sleep, because he has 2 dozens of projects to manage. What's more, the second program is integrated land management, and we're looking at a few things, mainly in the land reclamation side, soil restoration, land reclamation, biodiversity, and also atmospheric deposition of metals and organic. We're also involved with AEP and AMELA on the monitoring side, as Brad has mentioned already. The third program is oil and tailings management. One good example, Bruce gave you a very good example of what type of technology we are pursuing. We are actually, besides the EKS project, we are pursuing 2 other major technology. One is inline dewatering, also with major progress, and the third one is titanium membrane for the hot water recovery. And it's also moving into the demonstration. I should say, Bruce showed you a very good progression from the development to demonstration, and all these projects are in the same way. And on the sort of knowledge and applied R&D side, we are supporting 2 major chair programs. One is focused on the geotechnical, and another one is on the tailings water treatment on this side. And Rick Nelson, our tailings director, has been working very hard in the last couple of years, for us to play a role in the demonstration pit lake with COSIA, and hopefully the agreement will be moving along, and we're looking forward to this important initiative. Finally, we have the GHG capture program. I'm not going to go into this more detail because Vicky has given you a taste of what we've been working on this. What I should mention is between CCMC and the AI-EES, the carbon capture portfolio we have is really one of the best in the world. There is no question about that. And the only program probably outside of Alberta can rival this is from the US DOE. Really, we have a very strong portfolio on this. And this is very important for not only, we're talking about the GHG reduction, but also looking at the carbon utilization. The first step is you have to have those technologies to capture CO2 cheaply. So I want to finish my presentation on the thought that, our mission again is to, improve to have the superior environmental performance. The environmental performance in the resource development is challenging, there is no question, but it's not impossible. I show this here is the water usage in the in situ recovery. I think that's the best example. And the progress we have been made in the last 12 years, I think industry should deserve much credit for the main SAGD, but it's for the all in situ recovery. The water usage, whether it's the total makeup water in red or the fresh water makeup water in blue, has all decreased about over 50%, and in the freshwater situations is 2/3 of reduction. So it can be done. It's the GHG emission reduction is much more difficult, but it can be done. All right. So with this, I want to introduce our team. 4 of us you have seen already. Dr. Alexander Zander, probably some of you know him. He's an internationally renowned expert. And Rick Nelson is here as well. You heard Bruce made multiple reference to him. And Diane White is our competent program supporter. And I mentioned a couple of times, Brett probably don't get enough sleep in these days, but we are very close to hire a director of integrated land management to give Brett a bit of relief. So that's our team. All right, thank you. So I'm going to introduce myself again. So next one is again the tabletop exercise. So in the first exercise you've done, you identified what type of target is still relevant for our 2030 target is still relevant, or what new target needs to be at 2050. So this exercise, again, I will give you a few seconds to assign a moderator and a subscriber again. So there is a blue folder and a green folder on. Okay, so first is the blue folder. You should grab the blue folder. So the question is, again, you have identified the 2050 target. You helped us in the last session. This session is really talk about what kind of things we have to do to achieve those targets, 2050 targets, especially those things we are currently not doing. So this is the exercise. I think you have 7 minutes.